Why do you need to study this course? The main aim and objective to be world-class center of excellency in geosynthetic testing and other related product for the benefit of the mankind around the world. Enhancing how elementary theoretical knowledge and the observation of engineering performance assist and inspire creativity in the rational application of geosynthetic testing. The tests on geosynthetics are conducted in this course in two different ways. A index test or in isolation test. Tests are performed only on geosynthetics itself, and B performance test. Tests are performed along with the site specific soil. If we can perform the geosynthetic material along with the site specific soil, you can obtain some different value with respect to indexed or in isolation test. It is true that if you perform sometimes some of the test with the site specific soil, then you can have much more realistic value. Now we will discuss properties of the geosynthetics, physical properties, mechanical properties, hydraulic properties, endurance properties. Now what are the physical properties of the geosynthetic material? Mass per unit weight. Second, what will be the thickness of the geosynthetic material? What is the specific gravity of the geosynthetic material? What will be the stiffness or flexural rigidity or flexural stiffness? So, we will discuss one by one how we can perform the different physical properties of the geosynthetic material. Now we begin the mass per unit area as per STM-D 5261. What is our aim and objective for this test? To determine mass per unit area of geosynthetic material. Because mass per unit area vary. It may be 100 gram per meter square, 200 gram, 300 gram, 400 gram per meter square, 500, 600 gram per meter square. So, if the gram per meter square is more, the cost of the geosynthetic material also will be the more, but you have to select what gram per meter square geosynthetic material is required for the specific application and how you can perform the test. Now, in introduction, the cost of the geotextile is directly related to the weight of the geotextile. Weight of geotextile more means cost of the geotextile will be the more. An unit of the geotextile material is expressed as gram per meter square. What are the equipment and accessory required to perform the mass per unit area test? You require weighting balance with an accuracy of 0.01 gram and scissors. How will you proceed to perform the test? The procedure is like this. You take 5 test specimens of geosynthetic and whose size is 100 millimeter by 100 millimeter. Then weight of each test specimen is determined, and then you take the average value of the weight of all 5 specimens is recorded as a mass per unit area. So, this is the measurement equipment for the mass of the geosynthetic material. This is the equipment, this is the geosynthetic material whose size is 100 millimeter by 100 millimeter is placed in this equipment, and you measure that what should be the weight, and which is recorded as a gram per meter square. So, here some specimen calculation for the mass per unit area are given. You know the size of the sample is 0.1 meter into 0.1 meter, and area of the geotextile will be the 0.01 meter square. So, you note down serial number 1, 2, 3, 4, you have to perform 5, 6 tests. So, you measure what will be the weight of the geotextile in terms of gram. You can see here in the first test you have performed and measure the weight of the geotextile 8.975 gram. Next test you perform, it is 9.137 gram. Next, third test you have performed the weight of the geotextile 10.05 gram, and fourth test it gives the result 9.325 gram, and fifth test you are having 10.015 gram. So, you take the average weight of the geotextile material. So, average weight is about 47.502, because there are total 5 tests have been performed with 5 geosynthetic material. So, it is coming 9.500 gram. So, mass per unit area in gram per meter square will be 950.04 gram per meter square. So, mass per unit area of geotextile 950 gram per meter square, and gram per meter square is the unit for the mass per unit geosynthetic material. Now, next we have to determine what will be the thickness of the geosynthetic material. It varies, thickness of the geotextile material. It may be 0.25, or it may be 3 millimeter, 5 millimeter, 4 millimeter, 4.5, 5 millimeter, 8 millimeter. So, different types of the thickness of the geosynthetic material will be available for particularly for woven and non-woven geotextile material and its various application. So, here for the thickness of the geosynthetic material, we adopt the ASTM D5199, and main aim and objective of this thickness test to determine what will be the thickness of a geosynthetic material. In the introduction, you require geotextile exhibit different thickness according to the different pressure. So, if the thickness of the geotextile is measured to an accuracy of 0.02 millimeter under a specified pressure of 2.0 kilopascal as per standard, and thickness of the geogrid and the geomembrane are measured under a normal stress of 20 kilopascal, and thickness is generally vary in the range of 0.25 to 8.5 millimeter. So, you need the equipment and accessory required. Thickness testing equipment that can measure the thickness of at least 10 millimeter with an accuracy of at least plus minus 0.02 meter. Need thickness of the gauge. What is the procedure? Take a geosynthetics of sample size of 200 millimeter by 200 millimeter. Place the surcharge plate over the base plate and record the base reading. Place the specimen over the base plate and again place the surcharge plate over the specimen, and you measure the dial gauge reading is recorded. Here is the equipment where you measure the thickness of the geotextile material, and thickness is measured as a difference of initial and final dial gauge reading. here is a dial gauge, you can say 2 also the 4, and you take the reading by the dial reading in the initial and the final stage due to application of the load, and repeat the test for the remaining specimen. So, thickness of the geocentric material is taken as an average of the thickness of all specimen. Here, as I said, the thickness is measured of the geotextile material with the aid of this equipment, and this is the base plate, and this white color is the geotextile material, and this top one is the surface plate, and this is the dial reading, and this white one is the geocentric specimen. So, you can measure the thickness of the geocentric material with the aid of this equipment. Now, this is some specimen calculation for thickness of the geocentric material is given. This is sample number 1, this is dial gauge reading for 1 is initial dial gauge reading 0.620 and final dial gauge reading 1.503 for a sample number 1. Similarly, for the sample number 2, the initial dial gauge reading 0.972 and for the 2 the dial gauge reading is 0.511. So, you can determine that what should be the final gauge reading, final reading. This is 3.018, 2 for 3.846, 2.809, 2.875, and then you determine the thickness of the specimen. So, this minus this is 2.398, this minus this is 2.343, this minus this is 1.837 and this minus this is 2.365. So, average thickness of the geocentric material is 2.3705 and for these two samples the average thickness of the geocentrics is 2.1005. So, you can have the thickness of the geotextile material 2.2355 millimeter. So, this is approximately 2.2 millimeter thickness of the geocentric material. So, you should know how to determine the thickness of the geocentric material. So, in introduction, precipigravity can be defined as the ratio of the unit weight of the material to the unit weight of the distilled water at 4 degrees centigrade. You know how to determine the precipigravity of many material. Here only we have presented the precipigravity of different geocentric material. If the material is polypropylene, precipigravity is 0.91. If material is polyethylene, then precipigravity is 0.9 to 0.96. If the material is polyester, which is designated as PET, then precipigravity is 1.22 to 1.38. If it is a polyvinyl chloride PVC, this is impermeable material, precipigravity is 1.69. If it is a nylon, the precipigravity lies between 1.05 to 1.14. So, you can have some idea about precipigravity of the different geocentric material. Next is the mechanical properties, which is very important in civil engineering, and how to perform the different types of the mechanical properties of the geocentric material. There are various types of the test are available. So, one is the wide width tensile strength as per ASTM D 4595 and ISO Indian Standard Organization 10319. Now, why the wide tensile strength is recommended for the design for any infrastructure project. You have the very wide width tensile strength test, narrow strip tensile strength as per STMD 4751. So, this should not adopted for the design and not recommended. Shear and seam strength of geotextile as per STMD 4884 and ISO 13426, and graph tensile strength STMD 4632 and trapezoidal shear strength test. So, we will discuss, we will perform different types of the test, how to perform this test, and what will be the unit of the tensile strength of the geosynthetic material, which we will focus in our course. So, this is very important, wide width tensile stress as per STMD 4595. The main aim and objective to determine wide width tensile strength of a geosynthetic material. In introduction, basic difference between this test and other tensile strength test is the width of the specimen. Remember, width of the specimen. The reason for the necessity of wide width specimen is that geotextile, particularly the non-woven geotextile, achieve high Poisson's ratio value from the narrow strip test. Some geosynthetics have a tendency to contract under a force. The greater width of the specimen specified in this test method minimizes the contraction effect of those fabric. What are the equipment and accessory required? Tensile testing machine and strain rate is very important. The strain rate for the wide width tensile strength will be 10 plus minus 3%. If it is a ISO specification or international standard organization specification, the tensile strain machine rate will be 20 plus minus 3%. So, strain rate is very important. So, you remember what will be the strain rate of the machine for to perform the wide width tensile strength of the geosynthetic material, and that is 10 plus minus 3%. You need proper kind of the clamping arrangement and sufficient width to grip the entire specimen, that is very important, and area measuring device. So, you can see here this is the sample, and size of the sample is 200 millimeter and 100 millimeter is the gauge length. And we have performed the test in universal testing machine. Here is a clamp, so it should not be slip, it should properly grip, and before the test the sample has been loaded. This is white color is the non-woven geotextile material. You can see after performing the test, you can see there is a formation of the neck and sample may tear up. So, you can measure the tensile strength of the non-woven geotextile material. Similarly, another non-woven geotextile material before the test and after the test. So, it should be proper kind of the testing, proper kind of the failure of geosynthetics is necessary. So, this way we perform the wide width tensile test of geosynthetic material. Now, procedure for first mount the specimen centrally in the clamp, start the tensile testing machine and area measuring device. Tensile strength is directly measured from the instrument as maximum force per unit width to cause rupture. Now, it is also very important that how you can calculate the tensile strength of the geosynthetic material. So, tensile strength of the geosynthetic material can be expressed as a force per unit width. This is very important. That means T of geocentrics will be equal to F divided by W, and unit is kilonewton per meter. Remember, unit of the tensile strength of the geocentric material is kilonewton per meter, where F is the observed failure load in kilonewton and W is the specimen width is meter. That is why the unit of the tensile strength of the geocentric material is equal to F by W is kilonewton per meter, but not the meter square. So, specimen calculation for a wide width tensile strength. So, type of geocentrics, it may be geotextile, it may be geogrid, it may be geomembrane. So, observed failure load F is 4.20 kilonewton, let us say, and width of the specimen is 200 millimeter, that means 0.2 meter. So, wide width tensile strength is equal to F by W is equal to 21.02 kilonewton per meter. So, you can draw that tensile strength versus elongation, you can measure what should be the tensile strength and the corresponding the elongation of the geosynthetic material. So, next is the very wide width tensile strength. So, here the size of the specimen is 1000 millimeter to 0.5 times of the W. For design purpose, the very wide width tensile test is not recommended, and generally this we do not perform any kind of the test for very wide width tensile test. Narrow strip tensile strength as per STM D1682. The main aim and objective of this test to determine narrow strip tensile strength of a geocentric material. In introduction, the concept of this test is to record both the load and the deformation during elongation in such a way that a stress strain curve is generated. The stress strain curve is used to obtain the following value: what will be the maximum tensile load, what will be the corresponding strain at failure, what will be the toughness, what will be the modulus of the stiffness. So, from this test also you can perform all these tests and you can perform all this value. So, testing procedure: mount the specimen centrally in the clamp in a universal testing machine, start the tensile testing machine and area measuring the device, and here strain rate is about 300 millimeter per minute. So, tensile strength appear low compared to a wide width tensile test. So, this you can see this. This is the clamp and this is we perform the narrow strip tensile test. So, you have to calculate the tensile strength of the geocentric material and it can be expressed force per unit area. That means you know what will be the observed failure load and what will be the width of the specimen. So, you can calculate the tensile strength of the geocentric material. Next, geocentric material may tear. So, you have to perform some kind of the test and which is called the trapezoidal shear strain strength. When you dump this any kind of the material or gravel onto the top of the geocentric material may be damaged or it may be tear it off. So, it is necessary that what will be the trapezoidal shear strength of the geocentric material, and these tests are performed as per STM D4533 and ISO 13434. Here main aim and objective to determine the trapezoidal shear strength of a geotextile. In introduction, this test is done to tear the stress specimen from the point of initiation, and shear strength is important when the geosynthetics is damaged. So, this is the equipment and accessory required: central testing machine, cam, and the trapezoidal template. So, this is a trapezoidal tear test apparatus, and this is the size of the sample, and this is the trapezoidal in shape here. You can see here, and mark for the clamp here. This is the specimen, and this initial portion is cut, is 15 millimeter. This is 25 millimeter. This is the template. This is the template, and this is 100 millimeter. And this specimen is clamped in this universal testing machine, and you perform the trapezoidal tear test apparatus. This is very important. You should perform the trapezoidal tear test. So, procedure initially set the distance between the clamp as 25 plus minus 1 millimeter. Select the load range such that maximum load occurs between 15 to 18% of the full scale load. Mount the specimen clamping along non-parallel side of the trapezoid such that clamp is halfway between the clamps. Start the tensile testing machine and record the tearing force. So, how to calculate the tensile strength, trapezoidal tensile strength of the geosynthetic material? Tensile strength is directly measured from the instrument as the maximum force. Trapezoidal shear strength is measured in Newton N. Now, I am showing that some specimen calculation for the trapezoidal shear strength test. Type of geosynthetics: it may be the woven geotextile material, it may be the non-woven geotextile material. So, trapezoidal tear strength of woven geotextile material is 330 Newton, and if the type of geosynthetic material non-woven geotextile material, trapezoidal tear strength is 250 kilonewton. So, for different types of the geosynthetic material, you can obtain the different types of the tear strength of the geosynthetic material. So, this test is important because geotextile material should not be damaged. So, you have to specify proper strength of the geosynthetic material. So, if you use for any kind of the infrastructure where you have to dump the aggregate onto the geosynthetic material, either it may be woven and non-woven geotextile material, you should know that at what height it should be dumped onto the geosynthetic material in order that geosynthetic material should not be damaged. Because trapezoidal shear strength is very important. If there is any damage, also it can be rectified, also it can be teach, and there is a certain rules and regulation one has to follow. But if you perform proper kind of the testing, trapezoidal tear testing of the geosynthetic material, then it can be avoided. So, all the testing what I explained today, starting from your mass per unit area, thickness of the geosynthetic material, and particularly the wide width tensile strength of the geotextile is utmost important for design of any geosynthetic structure, and narrow tensile strength and the trapezoidal tear strength of the geosynthetic material. Thank you very much.